All right, so this is question number 12 of May 21, paper 1, part D. Now we're asked to use mathematical induction and the result from part B to prove that sigma um, arctan of 1 over 2r squared is equal to arctan of n over n plus 1 for positive integers of n, right? So for, as it is mathematical induction, first you have to use your base assumption n equal to 1. And uh, so we found that it is true for n equal to 1, and then I'm going to assume true for n equal to k. And if it's true for n equal to k, then it must be true for n equal to k plus 1. Now with mathematical induction, what you're supposed to do is you're supposed to use that n equal to k, what you found for n equal to k, to solve for n equal to k plus 1. And so this is for n equal to k plus 1. And instead of writing it as k plus 1 over k plus 2, which is what I'm trying to find, I'm going to write it as sigma r equal to 1 till k r tan of 1 over 2k squared, and then plus the value for k plus 1 plus the arctan of 1 over 2k plus 1 squared. Right. Now, as my space is limited, I'm going to go ahead and erase these extra points. Okay, and now from part B, we were given that arctan of P plus arctan of Q is equal to arctan of P plus Q over 1 minus PQ. So we're going to use that to write this as a single arctan. I probably should have substituted the value for the function for this before erasing it, but thankfully I have it in my head. So it's going to be arctan of k over k plus 1. So we're going to write this as a single arctan. So I'm going to continue writing it here. So arctan of k over k plus 1 and plus 1 over 2k plus 1 squared, and all of this over 1 minus k over k plus 1 times 1 over 2k plus 1 squared. All right, erase this. So for n equal to k plus 1, our goal is to write it, right, is to write it as arctan of k plus 1 over k plus 2. So have that in mind because it's going to be useful as we're solving it. All right, so arctan, I'm going to find a common denominator, and you can see they both have k plus 1, but this is k plus 1 squared. I'm going to multiply the denominator and numerator k over k plus 1 by k plus 1. So it's going to be k, and also don't forget the 2. So it's going to be 2k k plus 1 plus 1 over 2k plus 1 squared. Now, what about this? Well, I'm going to write that here. So this is 1 minus k over 2k plus 1 cubed. So the common denominator is going to be 2k plus 1 cubed. Instead, I'm going to write this as a multiplication. So the denominator will become the numerator now. It's going to be 2k plus 1 cubed. And the denominator is going to be 2k plus 1 cubed minus k. So the 2's cancel out. The k plus 1 cubed divided by k plus 1 squared. So the 3 will cancel out, and this will cancel out. So yeah. Continuing, so this will be arctan of 2 split by expand. So I'm going to expand this 2k squared plus k plus 2k plus 1 plus 2k plus 1 is multiplied by k plus 1, right? And divided by 2k plus 1 cubed minus k. 2k plus 1 cubed minus k. All right, so now I'm going to expand the denominator. So arctan of 2k squared plus 2k plus 1, k plus 1 over 2k cubed plus 3k squared plus 3k plus 1 multiply minus k. So if you further simplify the denominator, 2k Right, so if you first simplify, yeah, let's simplify. Let's multiply the 2 and the bracket. So 2k cubed plus 6k squared plus 6k plus 2 minus k minus k. Right? Okay. Now this is the part where it gets a bit tricky. So you have to pay attention here to write it as because our goal is to get this right here, right? And so let's see, we got 2k cubed plus 6k squared plus 6k plus 2 minus k. So I'm going to subtract the 6k by k, so this is going to be plus 5k, right? Plus 5k. Okay, so we got k plus 1 on the numerator. Now we need k plus 2 on the denominator. What if we divide this by k plus 2? Let's see how that goes. So I'm going to divide it here. So 2k cubed plus 6k squared plus 5k plus 2 divided by k plus 2, right? Because we need something to cancel out this 2k squared plus 2k plus 1 on the numerator. So if we divide that, let's see, 2k squared is going to be minus 2k cubed minus 4k squared. 2k cubes will cancel out, and we'll be left with 2k squared plus 5k, and we can write plus 2k. So this will be 2k minus 2k squared plus 4k. So the 2k squared will cancel out, and we'll be left with k plus 2. So we can plus 1. So it's going to be minus k minus 2. So the remainder will be 0. This is the function you got, right? 2k squared plus 2k plus 1. If you multiply, if you substitute in, instead of 2k cubed plus 6k squared plus 5k plus 2, you substitute in 2k squared plus 2k plus 1 times k plus 2. So 2k squared plus 2k plus 1 times k plus 2. This is your denominator now. Your numerator is 2k squared plus 2k plus 1 times k plus 1. So you can see you can now easily cancel out the 2k squared plus 2k plus 1, and you will be left with, finally you will be left with k plus 1 over k plus 2, which is what we wanted to find. That was our goal. So as you can see, we can say the left-hand side is equivalent to the right-hand side. Therefore, through mathematical induction, the function list is true for all positive integer values of n. Hope that helped.